Consider the compounds C4H8 and C4H10, define homologous series. It's a group of compounds that have the same, or group of organic compounds rather, that have the same functional group but differ from one another by a CH2 unit. Which homologous series does each one belong to? Well, this is your CnH2n, and this is CnH2n plus 2. So you're going to have an alkane and an alkene. When each of the two substances react with bromine, under the right conditions, what type of reaction will each compound undergo? Now the alkene will break its double bond and it will undergo an addition reaction. If you said it was a halogenation, that's even better. The alkane will need to get rid of two hydrogens before it can undergo a substitution reaction. And that is your classic differentiation between alkanes and alkenes. And your addition reaction will always happen much faster than your substitution reaction. Name the compound formed when the below compound reacts with bromine. So what's going to happen is that this is going to open up. You're going to have some bromine adding on both sides, and that's going to end up being 2,3-dibromobutane. What specific types of isotopes are illustrated below? So you're landing up over here with the double bond between 2 and 3, and here the double bond is between 1 and 2, so that is a positional isomer. Draw structural formulae for two chain isomers of C4H10. So it's got to be a chain isomer, and therefore I'm going to draw them out. So over here I have a single chain of 4 carbons, and obviously the 10 hydrogens on single bonds. Here the chain is slightly different. I am going to have a chain of 3 carbons and then a methyl group hanging off the side. So the chain has changed. A and B react in the presence of a catalyst to produce C. So we've got an carboxylic acid and an alcohol to form an ester. Name the product of this reaction. So we're going to divide over here on the O. Remember that this is your alkyl group, so that's going to be ethyl, and it came from the alcohol, and this over here is ethanoate. So that's quite nice because you couldn't really make a mistake with that. What is the chemical formula of the catalyst used? So that's sulfuric acid. It's actually concentrated sulfuric acid that you need to use, but they only wanted a chemical formula, so that wasn't necessary. Name the homologous series that C belongs to. It is an ester, which has a pleasant smell, and name compound C, ethyl ethanoate. Oh, sorry, what was the other product of this reaction I've left out? And you always get the byproduct of water. And it asks for a name, so you can't say H2O, you need to actually write the name water. The boiling point of ethane is minus 88,6 degrees, and butane is minus 0,5 degrees. Explain the difference in their boiling points. Well, you need to first say what's the same about them. So they both are non-polar molecules, and therefore it will be London forces between both of them. However, ethane is smaller than butane, therefore less electrons, and therefore less electron wobble. Or if you prefer, less instantaneous dipoles, and therefore weaker IMF and lower boiling point. The boiling point of ethane is given again, and chloroethane is given. Explain the difference in their boiling points. Well, the first thing is that ethane is non-polar, whilst chloroethane is polar. That means that this is held together by London forces, and this is held together by dipole-dipole intermolecular forces, and the dipole-dipole intermolecular forces are much stronger, and therefore greater IMF means a higher boiling point. 8.5. Ethanol can be involved in various reactions. Consider the scheme below. Ethanol, we're going to add butanoic acid, we'd get ethyl butanoate. Here we have got ethanol becoming ethanoic acid, and here we've got chloroethane having a substitution reaction where the chlorine comes off and the alcohol group goes on. Consider process number 1. Provide the name of the product of process 1. So that is over here, and that is going to be your ethanoic acid, as I just said. Consider process 2. Provide the name and structural formula of product B. It is going to be ethyl butanoate, and you now need to draw it. There's your ethyl group, separated by the oxygen from butanoate, which would have the double bond O, and then 4 carbons, and then we fill up on hydrogens. Name the a functional isomer. It has to be a functional isomer. In other words, it's got to have a different functional group, so it can't be another ester. And therefore it needs to remember the NH2NO2 is either a carboxylic acid or an ester. So we're going to look for the carboxylic acid that has 1, 2, 3, 4, 5, 6 carbons, and therefore you land up with hexanoic acid. What type of organic reaction is process number 3? It is going to be a substitution reaction where I take off the chloro and substitute on an OH group, and therefore I land up with an alcohol. Name the other product of this process. Well, if I've taken off Cl, the Cl will clearly have to join up with the sodium, and therefore you would get NaCl. And finally, we're going to draw the following compounds. So we are looking at tetrachloroethene. So it's ethene, double bond, and tetrachloro. Then they want butan 1-ol, but 1, 2, 3, 4, ol, OH. And then we've got the H's being added on here. Then methyl propane, so 1, 2, 3, and we have to add a methyl group, and there's only one place to put that methyl group, because if you put the methyl group anywhere else, you actually land up with butane, which is no use, because you need methyl propane. And finally, propyl methanoate. So I'm going to first draw my 3 carbons of the propyl group and give it the hydrogens that it requires. And then I'm going to put the dividing oxygen in, and then another carbon with a double bond O. And it's methanoate, which means I only have to now add 1 more hydrogen onto that.